negative 1 to the n plus 1. I'm going to separate it like this. Negative 1 to the n plus 1. Well, this is n plus 2 really. But I'm going to separate it as negative 1 to the n plus 1 times negative 1 to the first power. And then x minus 4 to the n plus 1. I'm going to write that as x minus 4 to the n times x minus 4 to the first power. N plus 1, I can't really change that. I'm just going to leave it the way it is. 9 to the n plus 1, I could write that as 9 to the n times 9 to the 1. Then change division to multiplication, and then flip the second fraction. So now let's cancel x minus 4.
People who pick post-university want a life on campus and online flexibility. Are you a post person?
What if I could build an app that works my way with Base 44? My work moves fast.
So this is the 1 over n plus negative 1 times x minus 4. And then the absolute value of negative 1 over 9, we can take that out of the absolute value expression and write it as 1 over 9. So what we have now is 1 over 9 times the absolute value of x minus 4. And this is going to converge when the ratio test is less than 1. So now what we need to do is multiply both sides by 9. And so these will cancel. And so now we have x minus 4 is less than is not. So now let's determine the interval. Say that x minus 4 is less than 9 but greater than negative 9. 9 plus 4 is 13. Negative 9 plus 4 is negative 5. So this is what we now have. Now let's rewrite the original series, which is negative 1 to the n plus 1 times x minus 4 to the n divided by n times 9 to the n. So just by looking at it, you could see that the power series is centered at c equals 4 because of the x minus 4 in it. Now let's check the endpoint. So let's replace x with In this video, we're going to talk about how to represent a function as a power series. So this is going to be the first example. Let's is less than 1. In this lesson, we're going to represent our power series starting from the n equals 0 value as opposed to the n equal 1 value. Now, a power series contains a variable x raised to the n power. So a geometric power series will be in this form, x to the n. In this case, a is 1, and so the sum for that is going to be 1 over 1 minus x. Notice that this formula looks very similar to that one. So therefore, this function should have a power series that looks somewhat like that, but not exactly like that. Now, this particular power series is centered at x equals 0. If you want to write a power series centered at x equals c, you can write it in this form. So it's going to be x minus c raised to the n power, where c is some number. So just keep that in mind. So let's start with this example. Right now, we need to write this function in the form of a over 1 minus r. So somehow we need to convert the positive sign to a negative sign. How can we do that? Now, it's important to know that a negative times a negative is a positive. So we can write it like this. 1 plus x is the same as 1 minus negative x. And so now it's in this form. So looking at this equation, what is a and what is r? So notice that 1 is equal to a and negative x is equal to r. So now that we have the a value and the r value, we can now write the geometric power series. So it's going to be in this form, starting from 0 going to infinity, a times r raised to the n. So this is going to be 1 times negative x raised to the n power. Now, negative x is negative 1 times x. So this is going to be negative 1 to the n times positive x to the n. And so this is our power series for this particular example. This is the answer. Now, there's still a few more things that we need to do. The next thing is we need to find the interval of convergence. So how can we go about doing that? So recall that the common ratio has to be less than 1 in order for the geometric series to converge. Now we know that the common ratio is negative x. So therefore, the absolute value of negative x has to be less than 1. Now once you have it in this form, the absolute value of x minus c, it's less than r. In this case, c is 0. But r is going to be this number if there's no coefficients in front of the absolute value symbol. So therefore, r is the radius of convergence, and in this example, it's equal to 1. Now let's determine the interval of convergence. The absolute value of negative x is the same as the absolute value of x, because the absolute value of negative 1 is 1. And so now we can get rid of the absolute value symbol and say that x is between 1 and negative 1. And that is the interval of convergence. So what does that mean? Before we get into the answer of that question, let's plot the interval of convergence on a number line. So it's centered at 0, and it's from negative 1 to 1. So we have an open circle at the end because negative 1 and 1 are not included. So when dealing with a geometric power series, you do not need to check for the endpoints because it's always going to be parentheses. The endpoints will never be included. And the reason for that is due to the fact that the common ratio has to be less than 1 in order for the geometric series to converge. Remember, if it's equal to or greater than 1, then the geometric series will diverge. So the interval of convergence for a geometric power series will never include the endpoints. So you should always have parentheses and not a bracket. What does it mean? It can be represented the function convergence. Now let's talk about what it means. So what does it mean that the interval of convergence is between -1 and 1? So recall that the function f of x, which is 1 over 1 plus x, it can be represented by the power series from 0 to infinity, -1 to the n, x to the n. Now let's write out the first 5 or maybe 6 terms in a series. So when n is 0, -1 to the 0 is 1, and x to the 0 power is 1. So the first term is 1. When n is 1, we're going to get -x. When n is 2, -1 squared is 1, and so it's going to be positive x squared. And then it's just going to repeat. So you can write out as many terms as you want to, and that's just going to it's going to go on forever. Now, this function can be represented accurately by this series only when x is between -1 and 1. So let's calculate the value of f of 0.5. So if you plug into your calculator 1 over 1 plus 0.5, or 1 divided by 1.5, you should get 2 over 3, which is 0.6 repeated. So I'm going to round that as 0.667. Now, 9 is a 5 cubed, 5th to the 7th later. Interval of convergence. Present the function as a power series and find the interval of convergence. So the first thing we need to do is we need to put it in this form, a divided by 1 minus r. So right now we're missing a 1. So how can we introduce a 1 into the denominator of the fraction? So when you're adding new numbers into the picture, you cannot change the value of what was there. So in the bottom, the value is equal to x. Now we can add 0 to x. 0 plus x is still x. But adding 0 won't help us. However, 1 plus -1 is equal to 0. And so that's what we're going to add to the bottom of the fraction, because the value of the fraction will still be equal to x. Now I need a negative sign between 1 and r. So I'm going to move this one to the left side. So right now I have 1 plus x minus 1. Now I need to turn the positive sign into a negative sign. So it changes. So notice that a is equal to 1 and r is equal to -x plus 1. So now that we have a and r, we can write the geometric power series. So let me get rid of this. So now let's use this expression. And then all we need to do is replace a and r, and then we could simplify it. So a is 1, we can ignore 1. You don't have to write 1. So we're going to have the summation symbol, and then r to the n, which is -x plus 1 to the n. Now, can we leave the answer like this? When representing a function as a power series, you want to write it in this form, x to the n, or you want to write it in this form, x minus c raised to the n. We're going to have, let me use brackets. So we're going to have brackets, -1 times positive x, and then positive 1 will change to -1. And this is all raised to the n power. Now I'm going to distribute n to the -1 on the outside and x minus 1 on the inside. So this is going to be negative 1 to the n power times x minus 1 to the n, starting from n equals 0, going to infinity. So this is the answer. That's the power series that corresponds to the function 1 over x. Now, we need to find the interval of convergence. We need to know the x values where 1 over x can be represented by that particular power series. So notice that this power series is centered at x equal 1, because if you plug in 1 for x, you're going to get 0. So we can say that c is equal to 1. Now what else do we know? We know that the common ratio interval of convergence, that's our next step. So for any geometric series, the absolute value of r has to be less than 1 in order for it to converge. So in this case, the absolute value of negative 1 times x minus 1, that has to be less than 1. So the absolute value of negative 1 is 1, so we could just ignore that number. So now we have this expression, which we can write this as x minus 1 has to be less than 1, but greater than negative 1. So if we add 1 to both sides, x is less than 2, but greater than 0. And so the interval of convergence is from 0 to 2. And you could see that c is 1. 1 is the midpoint of 0 and 2. The radius of convergence is basically this number that you see here, when you have it in the form of the absolute value of x minus c is less than r. So the radius of convergence is 1. So plotting it on a number line, we have 1 at the center and 0 and 2 at the end. And keep in mind, 0 and 2 is not going to be included for a geometric power series. It converges between 0 and 2, but at 0 and 2, the series diverges. So this is our c value, and this is r. Now let's try another example. So let's say we have the function 1 divided by 1 minus x cubed. Go ahead and represent the function as a form. So we could see that a is equal to 1, and the common ratio r is equal to x cubed. So we can write the power series using this expression. So we have the summation from 0 to infinity, and this is going to be 1 times x to the third raised to the n. So we can write the final answer like this. It's going to be x to the 3n third raised to the n. And this is going to be 1 times x. Now, if we decide to list out a few terms, when n is 0, x to the 3 times 0, that's x to the 0, so that's going to be 1. And then when n is x to the 3 times 0, that's x to the 0, so that's going to be 1. And then when n is 1, it's going to be x cubed. When n is 2, 2 times 3 is 6, so x to the 6, and so forth. And so this power x to the 6, and the x cubed 0, that's x to the 0, so that's going to be 1. And then when n is 1, it's going to be x cubed. When n is 2, 2 times 3 is 6, so x to the 6, and so forth. And so this power series is equal to 1 over 1 minus x cubed for certain x values. And those x values will be based on the interval of convergence. To find the interval of convergence, start with this expression. The absolute value of the common ratio is less than 1. And we can see that the common ratio is x cubed. So we could say that the absolute value of x cubed has to be less than 1. So thus x cubed has to be between one and negative 1. Now, if you take the cube root of each side of the inequality, you're going to get x is between 1 and negative 1. Therefore, the interval of convergence is just negative 1 to 1. And that's it for this problem. We're going to have the function 1 divided by 3 minus x. And we're going to do two things. Let's write the representation of this function as a power series, where it's centered at 0 and when it's centered at 1. Now keep in mind, when it's centered at 0, you want to put it in this form, x to the n. But when it's centered at some other number, you want to put it in the form x minus c raised to the n. So let's start with c equals 0. And let's have a 3. Somehow we need to change that to a 1. So what we need to do is multiply the top and the bottom by a third. So we're going to have 1/3 divided by 1 minus x over 3. And so now it's in the appropriate form. So we could see that a is equal to 1/3 and r is equal to x over 3. So writing our answer in this form, it's going to be 1/3 times r, which is x over 3 to the n. Now let's simplify the expression. So So 1 over 3, that's just 1 over 3 to the first power. And now let's distribute the exponent. So this is x to the n divided by 3 to the n. And now we can combine these two into a single number. So let's add the exponents, 1 plus n. So this is going to give us the power series, x to the n divided by 3 to the n plus 1, from 0 to infinity. So this is the answer. Said that the common ratio is this interval is the answer. Let's find the interval of convergence for this problem. And let's start with this expression. Now we said that the common ratio is x over 3. So therefore the absolute value, so this becomes,
They said that it was done, but they didn't really answer it back. They said I'm supposed to pick it up at the pharmacy, maybe. I'm gonna renew it. Okay.
is to multiply both sides by 3. And so the absolute value of x is less than 3. Now once you have it in this form, you can identify x is equal to centered at 0. Part of the answer, negative 3 to 3. And so this is the second part of the answer. Now let's go back to the original function, 1 divided by 3 minus x. And let's write the power series representation when c is equal to 1. So we need to put it in this format. That is x minus c raised to the n. And so that's going to be x minus 1 raised to the n power. Some sort of variation of that. So the first thing we need to do is get the x minus 1 term. So how can we get an x minus 1 expression in the denominator? How can we introduce it? And notice that we need the negative sign to be in front of it as well. So if we distribute the negative sign, this is negative x plus 1. Somehow we got to take a 1 from the 3. So let's break the minus x, which is the same as 3 minus x. So whatever changes you do, make sure that the value of the fraction remains the same. So now I'm going to write this as the value. The only thing I did is I moved the 1 to the right. Now the next thing I'm going to do is take out a negative 1 from negative x plus 1. If I do so, negative x becomes positive x, and positive 1 becomes negative 1. So now it's centered at x minus 1. And the value is still the same. 2 minus x minus 1, this whole thing is still equal to 3 minus x. Now it's almost in this format. The next thing we need to do is change the 2 into a 1. And so to do that, we're going to multiply the top and the bottom by 1/2. And so this is going to be 1/2 divided by 2 times 1/2, that's 1. And then this times 1/2, so I'm going to write it like brackets 1/2 and then parentheses x minus 1. Do not distribute the 1/2 to x minus 1. The x minus 1 part is your x minus c term. Now, it's in the appropriate form. So we could see that a is 1/2. So let's write that down. And what is the common ratio in this example? The common ratio r is 1/2 times x to the minus 1. So now that we have that, let's get rid of this. And let's determine the interval of convergence first. So let's start with this expression. So that means that the absolute value of 1/2 times x minus 1 has to be less than 1. So taking the 1/2 to the front, so we have this 1/2 x minus 1 is less than 1. So we need to multiply both sides by 2. So the absolute value of x minus 1 is less than 2. So now it's in this form. 1 is need to multiply both sides by 2. So the absolute value of x minus 1 is less than 2. So now it's in this form. And so the radius of convergence, we can clearly see that it's equal to 2. So now let's get rid of the absolute value expression. So we're going to have that x minus 1 is less than 2 and greater than negative 2. So now let's add 1 to all three sides. And so x is less than 3 but greater than negative 1. So the interval of convergence is negative 1 to 3. Now let's plot it on a number line. So it's from negative 1 to 3, and our c value is the midpoint of those two values. So c is 1. So this geometric power series will converge anywhere where x is between negative 1 and 3. This function is the geometric series centered at c equal 1. And so this function centered at c equal 1 can be represented by this particular geometric power series. Right now this is the geometric series, but once we replace r with x, then it becomes a geometric power series. So a is 1/2, r is going to be 1/2 times x minus 1 raised to the n power. Now this 1/2 outside of it, we can write it, I'm not sure what just happened there, but we can write it like this. It's going to be 1 over 2 to the first power, and then the n we're going to distribute to the 1/2 inside the brackets and the x minus 1. So it's going to be times 1 over 2 to the n times x minus 1 raised to the n power. So we can write the final answer like this. It's going to be from 0 to infinity, x minus 1 raised to the n divided by, and these two we can combine and write it as a single 2. So 2 to the n plus 1. So this is the series for 1 over 3 minus x, where the series is centered at 1. And you can see the x minus 1 term. Now that you've seen how to do the last example, you should be able to do the next one. Consider the function f of x is equal to 8 over 2x minus 9. Now what I want you to do is write a power series representation for this function, and this time we're not going to center it at 1, but let's center it at 3. So go ahead and try this problem. So if we're going to center it at 3, we need the expression x minus c, or x minus 3. And notice that there's a 2 in front of the x. So thus we're going to have 2 times x minus 3. And if we distribute the 2, it's going to be 2x minus 6. There's 2a negative 2x minus 6 minus 3. Now since I wanted to put it in the a1 over 1 minus r form, I need x to be on the right side, not on the left. So I'm going to move the negative 3 to the left side. Now this becomes 6. So now the next thing I need to do is take out the 2 and get x minus 3. In addition, I need to get rid of the positive sign. So recall that a positive number is the multiplication of 2 negative numbers. So what I now have is 8 over negative 3 minus, now I'm going to take out, right now I'm just going to write it like this for now. So I didn't take out the 2 yet, but these 2 negative signs, they will cancel to make a positive sign. So these 2 expressions are equivalent as of now. Now I'm going to take out the 2 from 2x minus 6. So this is going to be negative 2 times x minus 3. Now the next thing I need to do is change this number. To put it in a over 1 minus r form, I need this to be a 1. So I got to multiply the top and the bottom by what number? I need to multiply the top and bottom by negative 1/3. And so this is going to be negative 8 over 3. Since I'm running out of space, I'm just going to put this at the top. And then not change x minus 3. So as you can see, it's now in the appropriate form. 1/3, change it. And then keep this negative sign, let's not change it. And then negative 2 times negative 1/3, that's going to be, so we can clearly see that a, the first term, is 8 over 3, negative 8 over 3 that is. And the common ratio is everything inside the bracket. As soon as you identify a and r, you don't need this equation anymore. So now let's write the geometric series. So a is negative 8 over 3, and r is 2 over 3, x minus 3, and we're going to raise r to the n power. So this is the answer, but we need to clean it up a bit. So I'm going to write that as -1 for now. And then we have an 8. Notice that 8 and 2, they share the same base, a common base of 2. So I'm going to rewrite 8 as 2 to the third power. And the 3 on the bottom, that's going to be, rewrite -1, it's a negative sign. 2. So I'm going to rewrite 8 as 2 to the third power. And inside the brackets, 2 to the n power divided by 3 to the n power. And then times x minus 3 to the n power. So we can write the final answer from 0 to infinity, and then negative. Here we have 2 to the third times 2 to the n, so we're going to add 3 and n, and just write that as n plus 3 times x minus 3 to the n divided by, and here we have 1 plus n, or n plus 1. So it's divided by 3 to the n plus 1. So this is the power series representation of our original function, which was 8 over 2x minus 9. And this is true when it's centered at 3. And we can see 3 in our expression, x minus 3, which tells us that it's centered at 3.
Do you know the US Solar Company's nasty little secret? It turns out if you live in Connecticut, they have to give you solar panels for absolutely no cost. All you have to do is ask. Solar companies in the US are trying everything to keep this away from the public, but it's slowly leaking out, and it's all because of the
and the Maclaurin series for different functions. So let's start with this example. Let's find the Taylor series given the function f of x is equal to ln x centered at c equal 1. So what we need to do is basically write out the first 4 derivatives. So f prime of x, the derivative of ln x, that's 1 over x. Now to find the second derivative, we need to rewrite it and then use the power rule. So the second derivative is -1 divided by x squared. And then to find the third derivative, let's use the power rule again. So for the third derivative, it's going to be 2 divided by x cubed. And then to find the fourth derivative, it's going to be -1 times -2, that's positive 2. And then we need to take the derivative of x to the negative third power. So that's -3 x to the -4. So the fourth derivative is -6 divided by x to the fourth power. Prime of 1 is going to be 1 over 1, which is 1. And then the second derivative, evaluated at 1, that's -1 divided by 1 squared, which is just -1. And for the third derivative, it's going to be positive 2. And the value for the fourth derivative, when x is 1, is -6 divided by 1 to the fourth, or simply -6. So now we can get rid of this stuff. Now this is the formula that you want to use to write the expanded form of the Taylor series. So it's f of c plus f prime of c times x minus c to the first power plus f double prime of c times x minus c to the second power divided by 2 factorial plus the third derivative evaluated at c times x minus c to the third power divided by 3 factorial, and then it just continues. So f of x, which is ln x, is 1. And then the second derivative, that's going to be -1 So that's f double prime of c times x minus c to the second power divided by 2 factorial. And then for the third derivative, that's going to equal 2. So that's going to be plus 2 times x minus c to the third power divided by 3 factorial. And then we have negative 6 x minus c to the fourth power divided by 4 factorial. And then that's going to continue. Now let's simplify what we have. So we don't need to write 0. So we could say that the natural log of x is x minus c to the first power divided by 1 factorial, and then minus, well, I need to get rid of the c. This is supposed to be x minus 1 to the first power. And then it's going to be minus x minus 1 squared divided by 2 factorial, which is simply 2. And then plus, what is 2 divided by 3 factorial? 3 factorial is 3 times 2 times 1. And so we can cancel the 2. So therefore, this is going to be plus x minus 1 to the third power divided by 3. I'm just going to write this as 1 so you can see the pattern. And then we're going to have, this is going to be negative. Now, 6 divided by 4 factorial. Let's simplify that. 4 factorial is 4 times 3 times 2 times 1. So 6 will cancel with 3 times 2. So this is going to be x minus 1 to the fourth power divided by 4. So now we could see a pattern developing. So how can we write this series using summation notation? So let's start with n equals 0, and we're going to go to infinity. So when n is 0, we need to get 1 as an exponent. When n is 1, we need to get 2. And when n is 2, we need to get 3. So therefore, it's always 1 more than our n value. So we're going to have n plus 1. So this is going to be x minus 1 raised to the n plus 1 power. And since these numbers are the same, we need to have an n plus 1 expression on the bottom. Now the last thing we need to deal with are the alternating signs. It's going to alternate from positive to negative to positive and so forth. So we can either use negative 1 to the n or negative 1 to the n plus 1. Which one should we use? Now when n is 0 for the first term, we need to get a positive sign. Negative 1 to the 0 power is positive 1. So we need to use this one. And so I'm going to write that here, negative 1 to the n. So this is the Taylor series for the function ln x centered at c equal 1. And you can see the x minus 1 term, which tells us that it's centered at c equals 1. For the sake of practice,
the worst state to live in right now is Connecticut, and nobody's talking about it. I've spent 30 years in the insurance industry. What I'm about to tell you will explain why Connecticut pays more for car insurance than any other state in the country, and how you could fix it and save up to 80% on your rate. Let me make this simple. If you're paying over $75 a month, you're being overcharged. Drivers in Connecticut are being charged almost 2 times more for the same coverage compared to the rest of the country. Because you pay the most, the industry sees Connecticut as one giant cash cow, and most people have no clue why.
Let's go ahead and try another example. So find a Taylor series for the function f of x equals e to the x centered at c equals 3. So go ahead, pause the video, and take a minute to try this problem. Just like before, let's make a list of the function and its derivatives. So we have the function e to the x. The first derivative is going to be e to the x, as well as the second, the third, and the fourth. So all of the derivatives will be e to the x. Now, f of c, which is basically f of 3, that's e to the 3. And that's going to be the same as f prime of 3, f double prime of 3, and all of the derivatives, they will all be equal to e to the third power. Now let's write out the function. So f of x is going to equal f of c plus f prime of c times x minus c to the first power plus the second derivative times x minus c to the second power divided by 2 factorial, and then it's going to be the third derivative times x minus c to the third power over 3 factorial, and then that's just going to continue. So our f of x is e to the x, and f of c, or f of 3, that's e to the third power. F prime of c is going to be the same thing, e to the third power, but times x minus c
Guess it's installed already.